This is part 4 on functions. In parts 1 through 3, we went over relations and functions, definitions, different ways of writing relations and functions. Now we're going to work on using function notation, f of x or g of x or p of x, depends what the function is. And this gives you a rule for each input, how you're going to find each output. So we have to be given the rule, which is f of x equals 2x minus 3. In words, you're saying you're going to, if an x goes in, you're going to multiply it by 2 and subtract 3. So if a 0 goes in, f of 0, you're going to replace x with 0. So we have 2 times 0. Remember, this doesn't mean f times 0. This means f of 0. 2 times 0 minus 3. 0 minus 3 is negative 3. So that's what f of 0 is. All right, next one, f of negative 5. I'm going to replace the x. Remember, keep in mind that you have to be given the rule. This is the rule. So that's the rule I'm following here. I'm going to have 2 times negative 5 and then subtract 3. So that'll give me a negative 10 minus 3, which is negative 13. Here's the tricky one, f of m. You still follow the rule. You're going to replace x, right? What's in the parentheses is the x. So you're going to replace x with an m. So I look up at my rule. I'm going to put in m where I see an x. And we have 2m minus 3. All right, here's another function. I'm going to call it g of x because it's got a different rule, so I'm just giving it a different name. G of x is x squared plus 1. I want you to find g of 6 and g of negative 3. Be careful with your negative signs here. All right, for g of 6, what you're going to do is replace x with a 6. So this will be 6 squared plus 1. That's 36 plus 1 is 37. So there we go. That's g of 6. Now g of negative 3, all right, you're plugging in negative 3 for x, but you're squaring it. So you have to put the negative 3 in parentheses so that you make sure that you actually do negative 3 times negative 3. You don't want to just do 3 times 3. So this is really negative 3 times negative 3 plus 1, which is 9 plus 1, or 10. So g of negative 3 equals 10. Hopefully you're getting the hang of this. Let's do another one. All right, try this. If h of x equals x plus 1 over x minus 2, so now we have this rule. Find h of 0, h of 5, and h of 2. All right, try that on your own by putting the video on pause. Okay, for h of 0, we're going to put in 0 for x, so I have 0 plus 1 over 0 minus 2. So that's going to be 1 over negative 2, which is negative 1/2. All right, let's put in 5. 5 plus 1 over 5 minus 2 is 6/3, and that reduces to 2. h of 2. 2 plus 1 over 2 minus 2 is 3 over 0. Uh-oh, problem. Undefined. You cannot have a 0 in the denominator. Blows things up. Think of that as blowing things up. So when you have a 0 in the denominator, it's undefined. So in this particular case, 2 is not in the domain. Remember we talked about the domain? That's our input values, and our range was our output values. So now let's discuss a little bit about domain and range. The domain are the possible values you could put in for x, if that's your input variable. That's your input variable is x. And when you have a fraction, you cannot have a 0 in the denominator. So as long as the fraction is not 0, it could be in the domain. well, actually, there might be other problems, but that's one main problem to watch out for. So x minus 2, the denominator, is not allowed to be 0. So I'm going to say it's not equal to 0. So x is not allowed to be 2. So the domain here are all real numbers except 2. Let's look back at this one. G of x equals x squared plus 1. The domain are all the values that it's possible to plug in for x. Basically what you're looking for in the domain is there a problem? And is there anything you're not going to be able to put in for x? There is no problem. You could put any number in for x because you could square any number and add 1 to it. So the domain of this problem will be all real numbers. Let's look back up to the previous one. We had f of x equals 2x minus 3. Now that was a line. Remember that was a linear function. Again, are there going to be any problems here? You can put anything you want in for x. So the domain is going to be all real numbers. So the main problem to watch out for is if you have something in the denominator, make sure that it's not 0. Let's go back to this original function f of x and let's try a few more things. What if I asked you to find f of x minus 3? That looks a little bit strange, but all we're going to do is simply plug in x plus 3 wherever we see the x, okay? So we're going to just replace the x with an x minus 3 because that is what's in the parentheses now. So that'll give me 2 times x minus 3 minus 3. So that's 2x minus 6 minus 3, or 2x minus 9. Now, notice I'm inputting something with a variable, so that's probably why we're going to come out with a variable when we're done. All right, so following my lead, see if you could do this one. Find f of 4x. Put the video on pause and try that on your own. All right, so what are we going to do? We're going to replace x with 4x, right? We have to look back at the rule. We're going to put in 4x in place of the x. So this one will be 8x minus 3. Let's do one more. See if you could find f of x plus h. All right, what are you going to do? You're going to plug in x plus h where you see the x. You may be wondering why we're doing this. This leads us into some pre-calculus and calculus you'll be doing later. You're going to have to know how to do f of x plus h. It's very common. That's our answer. We can't combine any like terms. Let's step it up one more step. What if I said, what's f of x plus h minus f of x? Well, first we'd have to figure out what f of x plus h is, but well, we just did that, didn't we? There it is. So let's plug that in for f of x plus h. We've already computed it. 2x plus 2h minus 3, right? That's what we have for f of x plus h, minus f of x. Well, that's the original function itself. So we're going to actually plug in this, the 2x minus 3, because that's what f of x is. You do have to remember to put a parentheses around it. And now we're going to just distribute 2x plus 2h minus 3 minus 2x. And when you distribute that minus sign, that'll be a plus 3. All right, so what do we get here? The 2x minus 2x cancels. The negative 3 and the plus 3 cancels. My final answer here is just 2h. So that's what f of x plus h minus f of x equals. Now, if you could do some problems like that, then you're really getting the hang of it. And that's what I'm going to do on the next video. I'm going to step it up. So if you want to work with a little bit more complicated problems where you might have two different functions to look at the same time, or working more with variables like f of x plus h minus f of x. I'm going to go over those kind of problems on the next video.